Hey guys, Joe back at it once again with some A-level further maths topics, and today we're talking about interval bisection. So we're starting the numerical methods part and final part of FP1 actually, and we'll be moving on to probably FP2 after this. So there's three lessons on numerical methods. The last few lessons we've been looking at coordinate systems such as the parabola and the rectangular hyperbola, and before that we looked at induction, and many moons ago we talked about complex numbers, and we'll be revisiting that very shortly indeed. Not today, but in a couple of weeks probably. So here we go. The learning objective is to, I always forget to get my pen out, don't I? The learning objective is to understand how to show that there's a presence of a root between two values using the method of interval bisection. So that might sound a little bit confusing, but for years we've been solving equations and expressions either in our heads or using a suitable method like the quadratic equation or factorizing or whatever. But we've only been able to do this because the equations have been tailor-made to have nice answers. You know, whenever you do quadratic, you very rarely get answers of 1.2376773 2 to whatever decimal places. You usually get 7 and 5, or 2.5 and 1.5 or something like that. So they've been tailor-made to be nice answers, and examiners will always do that, except in this section of FP1 where you're expected to use numerical methods to kind of guess, and that's the problem with this sort of maths. It is just guesswork, really. But the reality is that most equations don't actually have nice answers and can't be solved with what we call pen and paper methods, and we'll talk a little bit about that in FP2 when we talk about homogeneous ODEs, but that'll sound very confusing right now. So the best we can do is to have a bit of a guess at the answer using calculators or computers. Computers are much better at it now. I'm not great with computers, so I probably wouldn't be able to do this, but computers can do it. So it's similar to the concepts learnt at GCSE when you did trial and improvement. I believe that's still on the spec, but the actual name of it is numerical methods. So I'll stop waffling on and we'll do an example. Show that one root of the equation x cubed minus 7x plus 2 equals 0 lies in the interval of 2 and 3. So what do we know about a root? It's not Joe root, by the way, so we're not talking about that. We're not talking about plant roots either. But it's where x is equal to 0, or where it crosses the x-axis, and that is what we define as a root of an equation. So we know that as it heads towards the x-axis, it's either positive or negative, and once it crosses, it will be the opposite. So think of a generic, I'll draw a little coordinate axis up here. I've probably done a diagram in the next bit, but think of a quadratic curve, and as this is coming down, your your y value is positive, and as it leaves, it becomes negative, and just here, it starts negative and becomes positive. So just think of that. There's something happening at the sweet spot, which is the root. So we're looking for a change of sign when we put the two numbers through the equation, and then we'll know that the point that is equal to 0 will be within the interval, because there's a change of sign, so it must have crossed the axes at some point. So if we put 2 through that equation, like we've been asked, because we've been asked to show that it's in that interval. So we'll put 2 through and we get minus 4. If we put 3 through though, we get 8. And therefore there's a change of sign, and therefore it implies that there's a root between 2 and 3. And that'll get you a mark in an exam, might be a couple, I don't know, it's probably a mark. And that it shouldn't say chagga of sign, it should say change. But I can't spell. But hey ho, I'm a mathematician, not an English student. So now what interval bisection allows us to do is make that interval smaller and smaller, and therefore increasing the accuracy, but never truly getting the root. So show that one root of the equation x cubed minus 7x plus 2 lies in the interval 2 and 3. We've just done that. And then starting with the interval 2, 3, use the interval bisection twice to find an interval of width 0.25 which contains this root. So as bisection suggests, it's just like loci. We keep halving the interval until we get an interval of a quarter. So putting a 2 through, -4, putting a 3 through, we got 8. That was a change of sign. Now we're going to try the interval of 2, 2.5. You could have chose 2.5, 3, but because 2 is closer to 0 than 3 was, I'm going to just do that. So when I put a 2.5 in to this equation up here, I got 0.125. Therefore, there was a change of sign that implies there was a root between, well, root between 2 and 2.5, but the way we write it is in the interval. So, next thing we do is try the interval 2.25 and 2.5, because 2.5 is much closer to 0 than 2 was, so I just chose that one. So putting a 2.25 in, you get -2.36. I don't know why I've wrote this out twice. It should really be that up there that I've got, so just forget this second line here. And because you've got -2.36 and 0.125, there's a change of sign which implies that there's a root between 2.25 and 2.5. Therefore, the way you write it is 2.25 is less than alpha, which is our root, which is less than 2.5, and we've found an interval where the root definitely is of a width of 0.25, and that's all that there is to it. Have I got another example? I haven't even bothered to do another example, but there's plenty of them. It's as easy as that. You just keep halving the interval. Sometimes they'll ask for a 0.125 interval, or maybe even a 0.5 interval. Just keep halving and looking for the change of signs, and remember to write it in that format. So hopefully you found it helpful. Make sure you leave a like if you did, because I need to know that. Good quality lessons. Any questions that you've got, leave them down in the comments, and I will try my utmost to answer them to the best of my ability. And yeah, I'll see you guys in a couple of days for, oh, what's it for? Linear interpolation, not to be confused with interpolation from Stats 1. See you then.